Let's talk today about muscle hypertrophy. Hypertrophy refers to growth, so muscle hypertrophy is the growth of muscle. So what causes the growth of muscle? What are the underlying factors? What are the things they have to do to develop larger muscles? Well, resistance exercise is the best way. I'm sure that I don't have to explain why. Resistance exercise such as weight training or resistance bands, anything that puts increased resistance on muscle, actually stimulates muscle hypertrophy because it increases the external load on the muscles, and it causes what they call an overload effect. In other words, you're overloading the muscle fibers, and you're forcing the body, if you do it right. When I say right, if you do everything else right, like not overtrain and use good form, the body will compensate by promoting larger muscles. But what are the factors that are underlie, I should say, muscle hypertrophy or muscle growth? There's for one thing, from a molecular point of view, you have something called satellite cells, which are muscle stem cells that lie kind of in between the muscle fibers. Normally they're quiescent. They're not doing anything. They just kind of sit there. However, when you do something that injures muscle fibers or damages them, there's signals that are set out, including hormonal signals from things like insulin-like growth factor 1 produced within the muscle that more or less turn on the satellite cells, and the satellite cells help to repair the damaged muscle fibers, and in so doing, they cause an increase in the thickness of the muscle fibers, which we recognize as muscle growth. Also, the satellite cells contribute what they call myonuclei, which is a site of protein synthesis in muscle. I don't want to get too much into technical detail, but let's just say that muscle cells are unique in that they have multiple myonuclei, whereas most cells only have one nuclei. Muscle cells can have several. And an interesting thing about myonuclei, again, that's the site of muscle protein synthesis that is basically the cornerstone of muscle hypertrophy or growth. The interesting thing about myonuclei is that once you develop a certain amount of myonuclei, if you stop training for a while, you don't provide any stimulus to the muscle will atrophy eventually. How fast it does this varies in individuals, but if there's no overload stimulus applied to muscle, it will atrophy or shrink. However, even if it does, the myonuclei that you develop doesn't disappear. It stays there. It just, again, stays dormant. Now, the interesting thing is when you start working out again, the myonuclei sense this, the protein synthesis increases again, and you get back the muscle size that you lost in most cases. Now, there's a certain caveats to this situation with satellite cells. For example, what happens is as you get older, it's harder and harder to activate these satellite cells. And in some cases, the satellite cells kind of disappear. You get like a deficiency of satellite cells. When that happens, it's extremely hard to get any type of muscle size or strength gains, although that's debatable. Some people say that the muscle satellite cells are not that involved in muscle hypertrophy, but the bulk of evidence indicates they are. I noticed this myself, the effect of satellite cells with age. When the gyms closed down, or because of the COVID pandemic, I didn't work out for about a month. I did no exercise whatsoever. I didn't have any equipment available other than a stationary bike. Later on, I got a friend of mine gave me a light set of weights, and then another friend allowed me to use a private training gym where I trained for almost a year and a half. But in that first month, I did no resistance training at all, and I noticed a surprising loss, I should say, of muscle size in only 30 days. I noticed this particularly in the peripheral muscles. That means the arms and the legs. Not so much the torso, the chest, and the back, but my arms and legs and deltoids, calves, actually had shrunk to an alarming degree. Now, here's the interesting part. When I was younger, for example, in my 20s and 30s, I could take layoffs as long as 2-3 months, which I very rarely did, but sometimes I did. and I would lose a minimal amount of muscle. I wasn't taking any drugs, but I did train hard and I lifted fairly heavy back then. I would lose more strength than muscle. And after about, let's say, 2 months of no training, my strength dropped. I would say, I don't know, it's hard to say, 15% maybe after 2-3 months. But the muscle size was surprisingly minimal. But now, at my age, if I don't work out, the muscle, as I told a friend of mine in the gym the other day, my muscle disappears like hot butter on a stove. If I don't apply constant overload resistance to my muscle, it just atrophies. This is something for guys over 40 to take into account. If you decide to take a layoff, you might want to do some minimal overload, minimal resistance training, using those resistance bands, something, because your muscles are going to shrink like crazy. And it's probably, it's not so much hormones, but I think it's a lack of overload resistance on and the fact that your satellite cells are not as active as they were when you were younger. You might have even lost some with age. They go through a process called senescence, where the cells just literally stop working. They just sit there. This happens throughout the body. It's one of the main causes of aging, but that's another topic. But one of the main ways to get larger muscles, again, is overload. Now, overload, in most people's minds, when you say overload, it sounds like heavy weights. And yes, heavy weights do help you to grow muscle. There's no question about it. As a matter of fact, if you lift heavy weights being defined as, let's say, 80% or more of 1 rep maximum weight, that's heavy. That's usually a weight you can do for no more than 6 to maybe 8 reps maximum. You can't do more than 8, usually 6 or even less, 4 to 6 reps. That's heavy weight. That'll activate most of the muscle fibers. You don't have to train to failure, as I said in a recent video. And that will definitely cause enough muscle damage to stimulate muscle hypertrophy. But that's only one form of overload. Overload can take various forms. For example, as I also pointed out, you can, for those of you who don't want to lift heavy weights, maybe because of joint problems or whatever, or you're older or afraid of injuries, you can get similar benefits as far as muscle growth to lifting heavy weights if you do a set that goes to 20 to 30 reps, and also it goes to near to failure. You have to, if you use weights that are equal to maybe 30 to 40% of 1 rep max, that's very light. That's a little bit. That's about the amount of weight you would normally use for a warm up. But you have to experiment and find a weight that you can do where you get to like the 25th rep and the muscles already fail, and you push it for maybe 3 or 4 more reps. You do it to failure, and that studies have shown will give you the same amount of muscle mass gains as lifting a weight that's equal to 90% of 1 rep back. So again, overload, that you could take different forms. For example, if you work out and let's say you keep a record of how many reps you do. Let's say one workout you do 6 reps, and the next workout you force out an extra 2 reps. Now you've done 8 reps. Even though you're using the same weight, you've increased the overload because you've done more reps. You've put more stress on the muscle. So that's still another way of overloading a muscle. Another way of overloading the muscle is to adjust your rest time between sets. If you rest less between sets, let's say 15 to 30 seconds, you're also putting more stress on the muscle. However, shorter rest periods are not conducive to strength gains. If you're interested in strength gains, you have to rest a minimum of 2 minutes and up to 5 minutes between really heavy exercise like squats and bent over rows, because it takes that much time for the muscle to recover its energy stores. And the energy stores are vitally important for increasing strength. But if you want to increase muscle size, you can get away with, let's say, 30 seconds between sets. And that, again, by reducing rest time between sets, that's still another form of overload. Now, what are the actual factors? There's 3 factors known to be involved in muscle hypertrophy. And I'm going to say at the onset, 2 of these factors are debatable. In other words, not all scientists agree that they play a huge role in muscle hypertrophy, but one of them is undeniable that all scientists who study muscle physiology agree on. And 3 factors are mechanical tension. Mechanical tension is the amount of let's say, stress you place on a muscle. This is the reason why overload or lifting weights causes greater muscle size gains than doing calisthenics, because there's more muscle tension, mechanical tension on the muscle, because there's greater resistance placed on the muscle. So mechanical tension is very important because, again, this is an overload that it causes what they call a chemical transduction effect. Well, again, it's kind of technical, but when you use a weight that induces mechanical tension, it converts mechanical energy into kind of chemical energy in the muscle. But again, I'm not going to go into details, extremely complex, but let's put it this way: it stimulates muscle growth. So mechanical tension is that's the most important factor. And again, you can get mechanical tension automatically by lifting heavier weights. You get it to a lesser degree by using the method I mentioned earlier, which is using lighter weights and training to failure. The lifting weights lifting lighter weights to failure technique activates another let's say important facet of muscle hypertrophy, which is metabolic stress. Metabolic stress is involved. That has to do with muscle fatigue byproducts. When you work out, such as lactate, these are produced when you do a set, let's say to failure, an extended set. Like that's why they suggest doing 20 to 30 reps if you're doing a lightweight to failure thing, because you want to get as much metabolic stress as possible. These metabolic fatigue byproducts or metabolic stress byproducts, like lactate and others, such as even the acid produced during exercise. The acid that's produced during exercise actually stimulates the release of growth hormone, but the metabolic byproducts are known to act as anabolic signaling factors in muscle, which actually stimulate muscle hypertrophy. So it's another way of stimulating muscle growth, metabolic stress. However, again, this is a debatable issue. It makes sense, but not all scientists agree that metabolic stress plays a major role in causing muscle hypertrophy. However, most scientists do think that there is some pretty definitive role played by metabolic stress. A subunit of metabolic stress is what they call time under tension. Time under tension increases metabolic stress. So how do you get time under tension? Time under tension just means the amount of time you're contracting the muscle. So in other words, if you do a set of, let's say we're talking again back to the 20 to 30 reps to failure, if you do it continuously, you don't rest between reps, you don't hold the bar. Let's say you're doing a curl, you just keep going nice and slow. You keep going, 2 seconds to raise it, 4 seconds to lower the weight, but you never stop. You keep the tension on the muscle all to the end of the set until you reach failure. That's time under tension, and that tremendously increases metabolic stress. The more time under tension, the greater the muscle growth, because again, they think it's because it increases metabolic strength. What's the third factor that's known to increase muscle size or muscle hypertrophy is something that's familiar to most bodybuilders, which is muscle damage. I mean, ever since I began training, I've read and I've been told that muscles grow because you damage a muscle fiber when you lift weights, and the body compensates by repairing the muscle fiber, and in doing so, it actually increases the protein deposition in the fiber, which translates into muscle growth. So muscle damage is definitely a factor. There's a big controversy. Well, it's an ongoing controversy because the thought is that you're kind of born with all the fibers you're going to get. In other words, the way muscles grow is like, let's say you induce muscle damage to the fiber by either training to failure with light weights or lifting heavy weights. And what happens is you get an activation of satellite cells. The satellite cells are involved in the repair of the damaged muscle fiber, and in doing so, it increases muscle protein synthesis, which causes the muscle fiber to thicken. It thickens, and that again is recognized as muscle growth on a broad scale. However, there are certain people that believe there's another process that can also cause muscle growth, which is what they call muscle hyperplasia. That involves the actual splitting of muscle fibers to form new muscle fibers. So you have more muscle fibers, which theoretically would be also indicative of greater muscle growth. They based this on several studies where they took biopsies of bodybuilders who had huge muscles. Some of these guys had 21-inch arms, and they compared them to inactive or sedentary college students who were basically pencil necks with like 14, 15-inch arms. These people never trained. So they expected the bodybuilders to have much more numerous, much more numerous muscle fibers, because they obviously had much larger muscles. But when they compared the muscle fibers of the skinny pencil necks to the huge bodybuilders under the microscope, they didn't notice any difference in muscle fiber size. They expected the muscle fibers of the bodybuilders to be much thicker and bigger than the sedentary students, but that wasn't the case. So the scientists who designed those studies concluded that another process had to occur, and they speculated that it was muscle hyperplasia, meaning the bodybuilders, after years of hard training, had stimulated the muscles to such a degree that the existing muscle fibers had split and formed new fibers. However, this has never been definitively proven. It's shown to be true, however, in various animal species, like birds regularly undergo muscle hyperplasia. They've seen it in cats. They've seen a couple of animals, but there's no definitive evidence to show that muscle hyperplasia exists in humans, despite those studies of the where they indicated that the bodybuilders didn't have larger muscle fibers. I think there was probably some sort of flaw in those studies, because it really doesn't make sense that a bodybuilder with a 21-inch arm would have the same size muscle fibers, or same number of muscle fibers, the same size muscle fibers as a skinny guy who never touched weight. It doesn't make any sense. So I believe those studies were flawed. And the consensus of most exercise scientists today is that muscles again grow by the existing fibers getting thicker rather than splitting or to form new fibers. And then there's another controversy related to muscle hypertrophy, which is that there's two kinds of muscle hypertrophy. One is called I can't remember the exact name, but myofibrillar. Myofibrillar muscle growth involves the proteins of muscle contraction, which is actin and myosin. They are stimulated by exercise, and they induce muscle hypertrophy and increase muscle strength. This effect on the actin myosin or myofibrillar proteins is generally accepted by exercise scientists as the main form of muscle hypertrophy. However, in more recent years, another type of muscle hypertrophy has been suggested, called sarcoplasmic hypertrophy. The sarcoplasm is kind of like the watery area outside the muscle. That's where glycogen is stored, and you have minerals in there, water, of course, and they say that a lot of the bodybuilders who have large muscles, it's not so much they have myofibrillar hypertrophy, but they have the sarcoplasmic hypertrophy, and just by its very nature, sarcoplasmic hypertrophy, if it does exist, would be much more sensitive to a rapid loss of size. In other words, if a bodybuilder, for example, took a layoff, the myofibrillar proteins, because of the myonuclei I mentioned earlier, would tend to last much longer. Whereas because of the fluid medium involved in sarcoplasmic hypertrophy, the muscles would shrink much more rapidly. And it's been a general observation, if you see even elite bodybuilders, sometimes they'll lay off after a contest, get off steroids, whatever. And by the way, steroids are also supposedly contribute to sarcoplasmic hypertrophy because of the localized water retention muscle. But these bodybuilders, when they lay off after a contest, very often they shrink very fast. I mean, you can see these guys, I've seen it, countless bodybuilders, elite, I'm talking champion level, where you see them 2 months after the contest, they're half the size. And they think it's, that's evidence of sarcoplasmic hypertrophy, meaning that they had big muscles, but it was more or less kind of fake. It wasn't real muscle. It was kind of the fluid portion of the muscle had expanded, giving the appearance of larger muscle, but it wasn't real muscle growth because the muscle proteins, like the myofibrillar proteins, weren't really affected that much. Now, this is a big debate. The truth of the matter is there's very little evidence to show the existence of sarcoplasmic hypertrophy other than what I just talked about, anecdotal evidence of bodybuilders getting these big muscles that kind of disappear real fast and this and that. It was like a very kind of a temporary muscle size. That's really the only evidence. Nobody's really demonstrated any scientific study that sarcoplasmic hypertrophy really exists. It's a theory. So, if you draw a line under it, you'd have to say maybe it exists, maybe it doesn't. Right now, the evidence is kind of up in the air. So that's basically I think I've discussed the underlying factors for muscle hypertrophy. Again, there's various avenues to muscle hypertrophy. You can lift lightweight and go to failure. You have to go to failure when you're lifting light weights, 20, 30 reps. Because again, the main reason why that type of training stimulates muscle growth is because of the increased metabolic stress, and you need higher reps to failure to get enough metabolic stress to stimulate muscle growth. Well, now, if you're lifting the heavier weights, which is 80% of 1 rep max or more, actually you can go down to 75% of 1 rep max, still heavy weight, you don't have to go to failure because you're going to stimulate all the muscle fibers, including the type 2X muscle fibers that are most amenable to muscle growth. I should mention that, again, you have different types of muscle fibers. Type 1 is called endurance fibers. Those are related to higher repetitions. They less subject to fatigue. Then you got the type 2. There's different varieties. Type 2A is a combination of endurance and muscle strength fibers. That's most bodybuilders have type 2A, which is, again, a combination of endurance and muscle strength fibers. And then you have the type 2X fibers, I should say. That's the real super strength muscle size fibers, and that can only be activated by using heavy weight. You can't get that by going to failure with light weights, which explains why training to failure with light weights, you can increase your muscle size, but you really won't increase strength that much because you're not really hitting the type 2X muscle fibers. The only really way to do that is through lifting heavier weights. There's no way around it. So, again, that's about it. Again, just to briefly sum up, the three main principles of muscle hypertrophy are mechanical tension, which is the amount of stress applied to the muscle, usually from resistance exercise, overload. Then you have metabolic stress, which is the metabolic fatigue byproducts produced when you work out, which act as anabolic signaling factors in muscle, stimulate muscle growth. And then you have muscle damage itself, which induces the body to compensate by repairing the damaged fibers and causing a thickening of the existing muscle fibers, which we recognize as muscle hypertrophy or growth. So that's about it. If you want more information on exercise science, nutrition, supplement science, anti-aging research, you can use today. And fat loss techniques that really work, ergogenic aids, hormonal therapy such as testosterone replacement therapy, women's health and fitness, many, many other topics. I cover more topics in my Applied Metabolics newsletter than any other digital publication, and nobody can really equal my nearly 60 years of study and in the trench experience in the gym. Nobody can match that to my knowledge. I've been a professional writer for about 40 years. I know how to write. I don't, unlike a lot of other digital publications, which are good, don't get me wrong. I'm not saying they're bad. They offer good information. The problem is that you almost have to have a little bit of a science background to read it, because all these other publications are written by people that have earned doctorates. They're kind of semi-scientists, and they're still stuck in that kind of medicalese type of writing where they use technical terms without explaining them, and they're written in a very passive, dry style that you have to have you have to be really motivated to get through those publications. I myself have a huge interest in science. I usually kind of fade out after I'm reading about a paragraph of those because they're just too thick. They're not interesting. They're not presented in an interesting way. They're written like a medical journal. They put all the reference. I mean, they're like medical journal articles. If you like medical journal articles, you like these others. I write in a magazine style because I wrote for magazines for 35 years. I know how to write for the public. I write at the level of 6th grade education. I'm not saying I write for stupid people. What I'm saying is I write in a manner that just about anybody can understand. The only requirement being that you're literate, that you know how to read. And even if you don't know how to read, there are programs free programs incorporated in, let's say, the Microsoft programs, that Windows programs, I should say, that will actually read the text for you. So even if you can't read, that you can have the text. You don't nothing to buy. You can set up. You do a Google search, it'll tell you. You can set it up in 2 seconds. It'll read the whole text for you. So that's about it. Subscribe today at www.appliedmetabolics.com. When you subscribe, I'll send you an invitation to join my private Applied Metabolics Facebook page, where each day I post new information on exercise, medicine, and nutrition. I have a email portal on my Applied Metabolics web page where current subscribers only, I don't accept unsolicited questions, can ask me questions about anything they read in Applied Metabolics or anything that comes to mind, as long as they're short questions. That's, again, only for subscribers. And Applied Metabolics is about, averages 30 to 40, even up to 50 pages every month. It's like getting a monthly ebook. There's no ads. I'm not trying to push any products. And I can absolutely guarantee what you're reading is 100% truth. I don't lie, and I also present both sides of an issue. So I'm not biased. I'm not presenting any opinion. I do, however, interject based on my almost 60 years of training experience. I always talk about what worked for me, which is admittedly anecdotal, but it could be useful to a lot of people. So I do include that also. So again, subscribe today. You won't believe me, you won't regret it. You will learn a lot. www.appliedmetabolics.com. If you want to have the best friend you'll ever have, adopt a dog. Go to your local shelter, adopt a dog. Also, those of you who have any suggestions for future videos, send them to Generation Iron, and they will refer them to me, and I'll see if I can do a video on them. So thank you for listening. Take care.